Okay, so this is Team 26, and my name is Bernardo, and I'll be demoing our code. So first of all, a little bit about the project motivation. Why at all do we need to have like a code to detect edges and detect objects in images? Well, that's because we need machines to make decisions. Nowadays we have like very automated like everything like industries and all that, and we need to have the machines operate like the human eye. And we can see in the picture like the human eye highlights some parts of the image, in this case like the head of the animal, and we need machines to do that sort of thing. And what sort of decisions machines take? Well, one example of that would be this cleaning robot that it takes images that it records from the camera, and and with that it knows like where to clean, where is dirty and where is not. So that's a bit of the project motivation. And hopping into the code, first of all, let me run it, and let me take the first image here. So just a little bit about our code while the project runs. This first loop turns it to grayscale, and then this next loop takes the grayscale image, the array, and then makes into a smooth image. This one makes this, we use the subble method to take the x dimension edges. This does the same thing, but with the y dimension. This takes the gradient of like adds the x and y dimension images. And this last one asks the user for like how sharp they want the edges, and then it finally outputs the last image. So let me show that. So if, for example, if the user type, I don't know, 0.32, we can see in the plots region that the final image is displayed, and on the files we can see that let me see, the grayscale image is right here. Yeah. Then we have the smoothed. Let me just get that. So you can see it's a little bit smooth, the image. And then after that, we have the X edges highlighted. Yeah, and you guys can see it. The Y edges. The gradient is over here. And finally, the threshold, the final image, is right over here. So yeah, you guys can see this is also displayed on the plots, and all these files comes from the code. So let me do one more example. And this time I'm gonna work with the, let me search that just a minute. And while we wait for our run to code, let me just explain the error detection we had. So you can see that the first thing the code does is ask the user for the name of the file, and then if the user enters a file that is not saved on the directory, or like he forgot, for example, to add this .png, the file extension, the code will stop running and tell the user what he did wrong. And after I showcase this last image, I can show that as well. Yeah, you see it asks again for how sharp, and if we put .23 just to be a little bit different, then we can see the images right here. And as of like just like the other one, all the grayscale and all the like in between images are saved here. So let me just show that. First one was a grayscale. This is a little bit smooth. It's pretty easily seen. Those are the X edges. The Y edges, and you guys can see that this replaced the old files. So the way we have it is like each time you run it, it like replaces the old one. So we would have like to save this on another file if we wanted to keep it. And this is the gradient, and finally the final image is right here, as it is on the plots. So let me just like one last time just show what we mean by the error checking. So if we put like, I don't know, the file saved as coin. So if I put it coin.png, it would say you entered the file name wrong, and it would stop running. So that's why our program checks for errors. And that was pretty much it. Thanks.